All right, welcome to the Phoenix LiDAR System, Phoenix LiDAR Systems May 2022 webinar. I'd like to introduce our presenter today. He is Corey Killam, our senior software engineer. You've seen him on trade shows, you've seen him at our webinars, and if you're lucky, you've even seen him on the Travel Channel. Corey, it's all yours.
Thank you, Lido. Yeah, welcome everybody. If you are new to Phoenix LiDAR Systems, new to our webinar series, we're excited to have you on here. We have a really good webinar for you today. A little bit of background about Phoenix LiDAR Systems. We specialize in building compact and customizable and adaptable survey grade mapping systems. And these can be fit on attached to cars or aircraft, helicopter, UAVs, backpacks, really anything that moves. And we also provide robust LiDAR post-processing software. So we have a couple of options. We have our automated cloud-based LiDAR processing software, LiDARMill, and we'll be touching on that today. We'll be going over that actually in detail today. And then we also have our desktop-based software. So Spatial Explorer Pro, if you want a little bit more hands-on experience and you don't necessarily want to have to rely on an internet connection, we have that option as well. And so why go with Phoenix LiDAR Systems? Well, we've been at this for a long time. We were actually the first company to provide a commercial UAV LiDAR system. And in doing so, we also provided the first real-time 3D point cloud visualization software so that while you're in the field, you can get real-time QC on your data and make sure that you don't have to return to the site and remobilize. You know that you're getting quality data right there on the spot, and you can be confident when you drive away. We also, being the first, we also had to create the first UAV LiDAR terrain following flight planner so that you can maintain a consistent altitude or AGL above ground level to ensure proper scan pattern within your LiDAR, proper data overlap and side lap. We were also the first to produce or to create a cloud-based LiDAR post-processing platform. So LiDARMill was the first of its kind. And very simply, if you have a surveying challenge, we have a surveying solution to fit your needs. When it comes to the complete package between hardware and software, we will fit your accuracy and criteria. What environment do you need to scan? What does your budget look like? And your overall capability. So we have a package that meets your needs. Like Lido was saying, today we have a really exciting solution comparison. We've been getting a lot of questions surrounding what is the difference between DJI's L1 solution that they offer, their payload package, versus Phoenix LiDAR Systems RECON-A. And really the only thing that's the same is the LiDAR sensor, but there are a lot of differences when it comes to other hardware components and certainly the software features that are offered. And so we will dive into that today. And by the end, I think you will have, I'm confident that you'll have a clear understanding of the differences, and we'll look at some data and you'll see the difference for yourself. So we'll start off with a overviews of the two different companies, us, Phoenix LiDAR Systems, and DJI, and how they differ. We'll then get into a hardware comparison. So comparing the different components between the L1 and the RECON-A. Then we'll get into the software comparison. We'll take a look at features and also dive into the data sets processed by Terra Pro versus LiDARMill. We'll save some time at the end for a question and answer portion. So as I'm going along and presenting, go ahead and if you have a question, just type it into the chat, and someone from our team will likely answer it along the way, but if not, we'll hold off to the very end and we'll have that Q&A portion. So yeah, we'll get all of your questions answered at the end. So let's start off with the company overview. And so what's the difference between Phoenix LiDAR Systems, us, versus DJI? Let's start with DJI. So DJI is a big company out of China, and they have about 14,000 employees. And they've recently gotten into the LiDAR industry about a year and a half ago in October of 2020 when they released the Zenmuse L1 payload. Basically, their objective is minimum viable product. They wanted to get to market, create LiDAR or offer LiDAR and essentially provide the capability of collecting LiDAR and then creating a point cloud. And we'll go over some of the key features that Phoenix LiDAR Systems offers in LiDARMill that are kind of lacking in Terra Pro. But so that's compared to Phoenix LiDAR Systems, us. We are based out of the United States, out of Austin, Texas. And we offer the RECON-A system. We have been in this industry for 10 years. This year is our 10-year anniversary. And we're a much smaller company. We have 40 employees. And what we focus on is a quality controlled complete solution from acquisition all the way through to post-processing and providing or generating deliverable paid data products that you can get paid for. And we really focus on our customers and ensuring the success of our customers, whether that's through technical support. So if you're in the field in North America and maybe you have a question while you're out in the field, you can call us on our phone number and we'll provide you with assistance. Or if you're post-processing back at your office and you need some help, we have a ticket system that, support ticket system that you can write to us, and we will generally get back to you within a couple hours with a detailed answer to help you through. So we really pride ourselves on creating the world's best adaptable LiDAR mapping systems for the commercial market, and ensuring that when you buy a system through us, you're really getting that return on investment. So let's dive into the comparison, the hardware comparison. So what is the difference between the DJI Zenmuse L1 on the left here versus the Phoenix LiDAR Systems RECON-A? So let's start with supported aircraft. The Zenmuse L1 is only compatible with the Matrice 300, whereas the RECON-A we have made compatible with a variety of aircraft. And we have integration kits to fit almost any aircraft. Feel free to reach out to us and we'll make sure that it can integrate with your platform. But we have an integration kit that can mount to those standard like M600 rails. So we've made it pretty easy and to integrate it with a variety of aircraft. When it comes to, we've already talked about the LiDAR sensor. They are identical for these two systems. So we'll move on to the camera. The camera in the Zenmuse L1 is actually a much smaller sensor, a 1-inch sensor, and providing 20 megapixels, whereas we have an APS-C sensor providing 24 megapixels. And we'll talk about that a little bit later more in depth as well. When it comes to a gimbal, the DJI Zenmuse L1 does offer one, whereas we offer a vibration dampening or vibration isolation kit. And we'll take a look at the data later on to see, does that gimbal really provide you with better accuracy, or what does that data look like compared to the vibration dampening? And when it comes to weight, the RECON-A is about half a pound heavier, and which is kind of a negligible difference in flight time. With price, we are slightly more. So there is the big question of why pay more for a similar system, and that is what we're going to cover today, and really focus on the quality of data and the outputs that that you can generate with LiDARMill versus what DJI has to offer. So yeah, starting with camera. Oh, I skipped over the IMU. So yeah, let's start with the IMU comparison. So all things the same, your LiDAR sensor and with GNSS accuracy being the same for both systems, the bulk of your accuracy is going to stem from the quality of IMU that you have. And one thing about IMUs is that they can drift over time. And so an important spec to pay attention to is the estimated gyro bias stability. So for the L1, the estimated gyro bias stability is about 2 degrees per hour, and compare that to the RECON-A's IMU 25, which the OEM spec is at half, is at 1 degree per hour. So in layman's terms, it's about twice as good. And actually, when we have performance tested it, we have repeatedly gotten 0.67 degrees per hour, so even better than the OEM spec states. If you take a look at DJI's known issues that are documented, The thing about having that lower accuracy IMU is that you can't fly for as long at a consistent speed. So the absolute accuracy of the point cloud gradually decreases after the drone flies for more than 100 seconds at a uniform speed. And this can kind of limit you. So for example, if the flight speed is 10 meters per second, the distance between neighboring waypoints should not exceed 1 kilometer, and that's stated by DJI. If we're comparing the camera sensors and the image quality, the image here shows a spectrum going from 2/3 inch sensor all the way up to a full frame sensor. And the L1 is on the lower end with a 1-inch sensor compared to the RECON-A, which has an APS-C sensor. And so what does this mean? Well, with a larger sensor, you get better image resolution, better low light performance, increased dynamic range, and decreased image noise. So overall, you're just getting a better quality imagery. So now let's take a look at the software and how does that compare between DJI's Terra Pro and LiDARMill offered by Phoenix LiDAR Systems. One thing to note here is that our Recon series is actually compatible with Spatial Explorer 7 Pro now, our desktop-based software. And if you want a more hands-on approach and more robust processing features, then Spatial Explorer, we can fit a package together with Spatial Explorer. But for this comparison, we wanted to do a more apples to apples comparison and compare their highly automated software with our automated software. So taking a look at software features, there are a couple similarities in features between LiDARMill and Terra Pro. The first being trajectory processing. Both can do it, and both can use a custom reference station coordinates. So that's important. Both software can create a point cloud and color it by RGB. And so you can get that real world color within your point cloud. Both can do some form of relative accuracy optimization. So that flight line to flight line matching. And we'll go over that in detail more on how they compare. And they can both also offer point cloud decimation. So let's say you're collecting a point cloud at 100 points per square meter. You could then decimate it down to, say, 10 points per square meter if you wanted to. Some key features that are not included in Terra Pro that LiDARMill offers are, let's start off with flight line splitting. So if you're doing that mowing the lawn pattern, your mapping mission, you want to just keep these straight flight lines, those straight parallel flight lines. If you use the turn data, if you don't remove it, then it kind of throws off your scan pattern, and those are lower accuracy points. So it's best practice to remove that, and Terra Pro does not offer that capability. Another huge, massively important feature is adjustment to ground control. And so we can utilize ground control in LiDARMill and use that during the calibration process to ensure the highest accuracy data set possible. And also, we have a cloud viewer. So once you are finished with the LiDARMill pipeline or processing process, then you can open up a cloud viewer. You can share it really easily with your end user. Just copy and paste a URL link and email it. And in here, you can do cross sections. You can view cross sections. You can view all kinds of visualizations, like you can color by classification, RGB, flight line, intensity values. But one important thing about LiDARMill is that you can actually classify your ground profile and extract, you can remove that vegetation and see your ground profile. And you can also classify noise. So you can do those basic classification routines within LiDARMill, but you can also do very advanced classification routines using our AI classification. So you can classify cars and transmission towers, buildings, transmission lines. A large variety of classifications can be automatically extracted from your point cloud, which is really useful. And then you can do point cloud filtering as well. So maybe you collect it with a larger field of view. with your LiDAR sensor, then you wanted to include in your point cloud, you can reduce that down. Maybe there were some like image frustrums that you don't want to include on the corners of your trajectory or on your turns, so you can eliminate those. It gives you a lot of options. And some of the most important things are QC reports. So every step along your processing journey, if you will, you can verify that the quality of your results. So when you're processing your trajectory, you can look at a QC report to ensure that meets your spec before you create a point cloud from that trajectory, for example. And when you create your finalized LiDAR point cloud and classify it, you'll have a QC report giving you absolute accuracy and relative accuracy and all the information that you want to see from a final deliverable report. And you can also generate products. So these you can actually get paid for. You can produce digital elevation models. You can produce contours, all kinds of different products. And none of this is offered in Terra Pro. The way that LiDARMill handles orthomosaic generation is by outputting a Pix4D DAT file, which has the extrinsics for your camera. And you can put that into the industry-leading Pix4D software and generate an orthomosaic. Terra Pro has included this orthomosaic capability within their software, but later on we'll kind of discuss how that quality compares to Pix4D. Some other features that are lacking in Terra Pro that LiDARMill offers is that shareable data viewer I was discussing, which in there you can generate fly-through videos, you can take measurements, compute volumes, visualize your ground control, and we make it really easy and very user-friendly. And then one of the final software features offered by LiDARMill is Cloud Clean, and that is kind of cleaning up the imprecision from low precision scanner and removing some of that noise. So we'll take a look at that a little bit. Yeah, I wanted to get a feel. I called John Philippe up. He's the director and spatial solutions manager at Orion Spatial Solutions, and he has years of experience in the geospatial world, and he is a mapping and surveying professional. And he purchased one of these DJI L1s, and I wanted to kind of get his feedback and how he felt about it, as he has used Regal systems and all these other LiDAR systems on the market. I wanted to see how they compared. So I had a call with him, and some of the feedback that I received was that DJI Terra Pro lacks all the tools needed for accurate surveying. He added that unless you have a third-party package to process that raw data, the results from DJI Terra Pro were essentially unusable. And there's really no ability to take control of your data at all in Terra Pro. He was saying it's very black box. You put your data in, you upload it, and you kind of hit process, and there's not much you can do to fix things or correct things when they go wrong. And one of the biggest takeaways is it really only gives you step 1 out of, say, 6 steps. The DJI package leaves you on step 1, and you've got to do the rest. So without having a variety of other LiDAR processing packages, it doesn't quite get you where you need to go. It doesn't classify your point cloud. It doesn't produce data products, and it doesn't really give you any sort of usable reports. There is strip adjustment, some form of strip adjustment in Terra Pro, but what John was saying is it doesn't actually work. So there's just no real strip adjustment, and they have had many projects with huge steps in the data. One thing that he was referring to with the no strip adjustment is when you have multiple missions. Maybe you did one flight one day, another flight another day, and you want to, and they're right next to each other, overlapping, and you want to combine those data sets. That's where the strip adjustment just doesn't work. And he sees huge steps, many times upwards of a foot. And because of these steps in your terrain model, it's just, the software is not suitable for producing terrain models, because at that point, your terrain model is just so inaccurate. And finally, when asking, he had this issue with, he wanted to get a geoid for Australia, and that geoid wasn't available in Terra Pro. And so he reached out to tech support to ask about getting that geoid to output to orthometric heights. And they essentially responded with, we don't support that for your country, and it's not on the roadmap. In contrast, if something like that came up and we didn't offer the specific geoid you're looking for, simply contact us and we will get that geoid input to LiDARMill. But as is, we currently support every global coordinate system. And with Spatial Explorer Pro, you can actually utilize local coordinate systems. So when it comes to orthomosaic processing, he was saying that the quality of the orthomosaic is pretty low. So they would inevitably end up putting that imagery back into Pix4D Matic, and they didn't actually end up using DJI's ortho package on any projects whatsoever. He said it's a simple workflow designed for someone who is not a surveyor looking for accurate data. Once again, pretty black box. And when it comes to technical support, I was asking him what kind of the turnaround time would be. And he said within 48 hours, you could probably get an email response, but it doesn't really get you anywhere. Most of the time, it's something along the lines of, sorry, we don't support that, or sorry, we don't have a solution to that. And he hasn't been able to get them on the phone. Once again, we will get back to you within hours if you email us, and we're available by phone in North America if you're having some issues in the field. So now to the fun part. Let's take a look at the data processed from the L1 solution with Terra Pro. So we can see that here in green. And let's compare that to the RECON-A data processed in LiDARMill. So we have two versions of this data set, the red, which is RECON-A plus LiDARMill optimization. And then we have the blue data set, which is using our Cloud Clean feature. So it is computing an average surface along any feature, whether that be a roof line, like we see here in this cross section, or ground, or a wall, lamppost, anything like that. And then it basically projects the lower precision points to that surface. And so what we're seeing here is that with the L1 and Terra Pro optimization, we're getting about 20 centimeter thick profile on this rooftop, on this low reflectance roof. With the RECON-A and LiDARMill, without using Cloud Clean, it's reduced to about half, about 12 centimeters. And this is multiple flight lines, keeping in mind. And so relative accuracy plays a role here in that strip adjustment. And then the blue is showing the Cloud Clean feature, and we can actually get that rooftop down to 1.5 centimeters while maintaining the same point density. So what does that look like in absolute accuracy? We talked about relative accuracy. Now, what about absolute? Well, we scan the same site with the L1 and with the RECON-A, and we have 38 GCPs out there on the site, shown in the upper right. And if we're looking at absolute accuracy, the standard is root mean square error in the Z. So basically, what is the vertical offset between a GCP and your point cloud, more or less? So it's about, we were able to achieve about 8.9 centimeters, so right around 9 centimeters absolute accuracy for the L1 with the Terra Pro optimization, compared to about 3 centimeters, 2.9 centimeters with the RECON-A and LiDARMill optimization. And that was slightly improved using the Cloud Clean. One really interesting thing to notice here is the minimum and maximum delta Z. So what were the minimum and maximum offsets between a ground control point and the point cloud? And if we take a look at the L1, we're seeing a minimum delta Z of 30 centimeters, which is right around a foot offset from ground control. And to compare that with the RECON-A without Cloud Clean, it's about plus or minus 6 centimeters. And then with Cloud Clean, right under plus or minus 5 centimeters. And so in this screenshot, what we're showing is an overview of the site. So we flew this site with north to south passes, and so up and down in this picture. And then I wanted to take a look at why are we seeing those 30 centimeter offsets? So If we take a profile from the left side of the data of the site, we're noticing that the green data set in that bottom left profile is significantly above where the RECON data is. And keeping in mind that the RECON data is about 3 centimeters real absolute accuracy. And there's a white X in both of these profiles to show where the ground control point lies. And then if you compare that to the right side of the data set, the green L1 and Terra Pro data is actually below, and is significantly below, ground control and where it should be. So there's this warping effect happening. And to take a deeper dive into this, I've prepared a video. So let's take a look and take a deeper dive into this data set. Hello and welcome to the DJI L1 versus Phoenix LiDAR Systems RECON-A data comparison. So we've processed 3 data sets here, and right now I'm just coloring this by flight line or point source ID to show you that the flight lines were flown north to south in both data sets, or in all 3 data sets. And I've gone ahead and classified each data set to a different classification and colored by classification. That way, when we take a profile, we can easily distinguish between the 3 data sets. If we take a profile across our point cloud and across our site from west to east, perpendicular to where to the flight lines, we can zoom in here and we see that the green thick data set is the DJI L1 data processed in Terra Pro. And we can take a measurement here and we see that on this particular hard surface we have about a 11.2 to 13.4 centimeter thick profile. And that's that green data set. And then the red data set is the RECON-A data processed in LiDARMill. And that is on the order of about 7.5 to 8.5 centimeters thick. And that's just using our traditional trajectory optimization routine in LiDARMill. And then the blue data set is about 1.5 centimeters thick, and that's using our Cloud Clean tool within LiDARMill to compute an average surface and then project the less accurate or noisier data to that average surface and clean up the imprecision a little bit. So now if we make our way to the right side of this profile, on the right side of the data set near GCP 27 over here, we're going to zoom in to around GCP 27 just to take a look how the data differs from the left side of the data set to the right side. So the left side of the data set, the L1 data can be seen above. The green data set was above the RECON-A data set. And here on the right side, it's significantly below. And if we measure here, we'll see that the L1 data set is about 15 centimeters below this ground control point 27. And the RECON data presented here has an absolute accuracy of 2.9 centimeters across the board with 38 GCPs. So from our control, we notice that the DJI L1 data with Terra Pro is significantly below and is warped, whereas the RECON data is about 2 centimeters off here. And so without the ability to add in ground control points to the calibration process and the flight line matching process or strip alignment process within Terra Pro, you can start to get this warping that occurs as it begins matching flight lines across an AOI. Whereas LiDARMill, you can implement ground control during the calibration process and use that to certainly constrain your data set. Even without ground control points, though, we have a different strip alignment routine, and we do not see this warping that is occurring here. So what I'm doing here is I just took a profile across the site again. I'm just moving from the west side or the left side to the east side or the right side, and you know, we noticed that on the far left, the green L1 data was significantly above the recon data. Here, about a third the way through, halfway through, we noticed the data sets. We notice a difference in imprecision, but they're more or less aligned. And so if we keep moving our way to the right, we'll notice that once we get to these rooftops, we certainly notice a difference in imprecision between all the data sets, with the L1 data set being significantly thicker than both recon data sets. But right there, right after the peak of that roof, the green L1 data set begins to drop below all the other data sets, or below the recon data set, and begins warping down. And so here on the right side, below GCP 27 again, we see that warping or distortion occurring. And if anybody wants to check out this cloud viewer, we'd be happy to share a link with you to view this for yourself and to take your own cross sections. So just contact us at the end. When it comes to the final comparison will be the report comparison. So Terra Pro's report is on the left here, and this is what it offers as a they call it a LiDAR quality report. Most of what you will see is processing times and maybe a processing parameter here or there, but there's no indication of how good your relative accuracy is. What does your absolute accuracy look like? And it's pretty bare bones. It doesn't give you a lot of valuable information. Compare that to LiDARMill's reports, where every step along the way, you'll have a QC report. So for example, with trajectory, with your trajectory report, you will be able to see the positional separation and attitude separation before you even generate a point cloud. So you'll know if you're within tolerance, and your point cloud will turn out highly accurate. And then once you create a point cloud, you'll have a project report for your end user, giving the end user all of the information they need to ensure a quality product, like absolute accuracy, relative accuracy, when was the data collected, when was the data processed, which coordinate reference system was utilized, gives you point cloud statistics, all kinds of things. And then also, you know, it can give you your flying height, your flying speed, all those acquisition parameters. And there's also a processing report that is more for the person that did all the processing, and it documents all of the settings that were used and all of the calibration parameters. So in summary, you truly get what you pay for. And to run through the differentiators, in summary, we have for hardware, the RECON-A simply has a superior camera. It offers you a 24 megapixels versus 20 megapixels. You get better, more accurate data using the RECON-A's superior IMU, 0.67 degrees per hour versus the 2 degrees per hour that the L1 offers. So significantly less drift in your inertial navigation trajectory. And the RECON-A is adaptable to various aircraft, so you're not just limited to the M300 as you are with the L1. The software is the biggest differentiator, certainly. And when it comes to processing, like John was saying, it really leaves you, Terra Pro leaves you on step one of about 6 steps that you need for a fully functional LiDAR post-processing. So LiDARMill gives you the ability to split flight lines, to do true flight line calibration, to classify your point cloud and produce data products that you can actually get paid for. And also utilize ground control points and determine, you can use ground control, you can separate your GCPs from control points and also independent checkpoints. So you can use some ground control to vertically align your point cloud, and then other independent checkpoints to assess your absolute accuracy. And then finally, LiDARMill offers superior detailed processing reports, just like we went over. So that's trajectory processing reports, LiDAR and imagery processing reports, and project reports. And at this time, I'd like to announce that we are doing a promo for our RECON-A package, our RECON-A solution. And if you purchase a RECON-A system before June 30th, so you have all next month, we will actually include a free 1-year subscription to LiDARMill. So that will definitely bring the cost down. And at this time, I just want to thank all of you for attending this webinar, and I hope that I've answered all of your questions pertaining to the differences in the L1 versus the RECON-A solution. But if you still have some questions, I'll invite my team to join us for this question and answer portion, and we'll get the rest of your questions answered. So I'll hand it back to Lido at this point.
All right, thank you, Corey. Yeah, we do have a few questions here. I'm trying to get control back of my mouse. Hold on a second. The first one is, let's just go ahead and dive into it. Corey, can we import raw L1 data into LiDARMill for processing?
Ha! I've heard that question before.
A little bit. This is Dr. Ben Adler, our CTO.
Hey, Dr. Ben. Dr. Adler, what's up?
Hey, thank you, Corey. Great job. Yeah, we thought about it. I guess we're thinking about it. Generally, that may be possible. For us, it's a bit of a, I guess, a compromise, because the worse the input data is, the more you have to correct it, obviously. Yeah, we don't want to produce bad data on LiDARMill, because it really, if we want to support what we do, then it becomes this support nightmare of, oh, my flight lines drift and this and that. So we're only going to do it once we can produce data that matches our standards, really, because otherwise we'll just have unhappy customers. And yes, we're working on it. I can't say if it'll be good enough, or at what time it'll be good enough. So the answer is probably soon.
Well, we have a related question. Ben, is LiDARMill available for yellow scan systems?
Not currently. There is, yeah, some means of processing that, but it's not like a, it's not in LiDARMill, and it's not a polished workflow. So currently, no. If you wanna try, then hit us up, and maybe we can see if we can make it work together, and then yeah, see if it fixes your pain. So yeah, please contact support@phoenixlidar.com if you would like to try something.
Okay, here's an interesting question. What's the main point of having a gimbal with a LiDAR system? With just vertical faces? I'd assume the vibration damping system on the would produce the same results if the L1 was at 90 degrees.
I can't really answer why DJI would have done that. Technically, of course, it gives you the option of using the gimbal to increase your field of view and start moving it around to, I guess, get some kind of a sweeping motion and scan vertical structures. And in theory, that may work. But yeah, as of now, I think there's enough issues with not using the gimbal. So maybe in the future it'll be useful. Who knows? I can't really answer that question. I don't know, Corey, if you know more about this.
Yeah, I don't have anything to add to that. I think that was well answered. Yeah, just getting some the vertical surfaces, but as you mentioned, the accuracy of the data is already lacking, so they have a long way to go.
Right. You had mentioned in the presentation that the RECON-A system is compatible with lots of different aircraft. Someone is asking what options, what aircraft drone options are compatible with the sensor. Do we have can you give a list and rattle off some names?
I can't. I know we have some adapters to other UAVs. Like it comes with a Skyport adapter, but or Skyport, I guess. But there is some adapters to adapt, and I'm not quite sure. I think there's some free fly options. I think there may be some Harris options, but I'm not too much in the UAV domain, so I'd rather want to be careful. Hit us up if you have a UAV that you would like to fly it on, and yeah, they are flying on non-M300 systems or also on non-DJI systems.
Yeah, we are definitely selling them with M300, and we also do have a Skyport adapter that works with the M600 as well. For all of you old M600 fans out there, and we still use that UAV platform on a regular basis as well. So,
and I believe that means it works with the 12mm rails, right?
That's correct. Yeah, any 12mm rail system it should be able to adapt to within reason. Okay. Let's see here. Is Cloud Clean and Is Cloud Clean and I'm having trouble speaking today. Is Cloud Clean incorporated somewhere on SE7 Pro? SE7 is the latest version of our Spatial Explorer software.
100%. Yep, that's in Spatial Explorer 7 Pro as well.
And here's a comment. Someone commented that the camera on the L1 has a global shutter, which no other camera has. Is this an advantage or that the L1 has over the A6K light that we have on the Phoenix RECON-A?
I'm actually not sure if the L1 has a global shutter or if it just has a mechanical shutter. I think the sensor isn't global shutter, but I may be misspeaking. Really, it's the I guess what matters is to know how your camera exposes or what parts of the sensor are exposed at what time. And so long as you know exactly how that works, there is math to come to accurate conclusions. And I guess generally speaking, when we calibrate these cameras, we can figure it. So we detect features and images and we match them, and we then convert that into 3D geometry. And with these systems, we can get those like 3D rays in space to coincide down to like an average of 7mm. So yes, it is not a global shutter camera, but so long as you know your sensor's characteristics and you compensate for that, it doesn't really matter. In fact, it's an interesting opportunity for optimization because an image doesn't really capture a moment, it captures a time window. And if you really invest a lot of work, this is actually, it starts being an advantage. But yes, it also brings its challenges, I guess.
Okay, here's another one, and I think you might have touched on it already as well. Does the GNS system have RTK and PPK, or PPK?
Technically, I believe you can do RTK, but there's really no reason you would want to. The system doesn't stream real-time live data, so there's really no point in RTK. If you would want to do like a quick data check in the field, you can do that using just single point unaided. Oh, sorry, one second. Unaided GNSS, which would be accurate to, I don't know, 1, 2, 3 meters. But just to see if you captured what you wanted to capture, that's good enough. And really, the whole setup of streaming RTK corrections, like for this system and its use cases, I believe isn't really worth the trouble. Yeah, but PPK, of course, yes, it does capture raw GNSS observations, and yeah, you run the classic post-processing pipeline on it. So there's really no difference to the other systems there.
And here's another question that I'm sure was covered before. Do we offer point cloud colorization?
Yes, absolutely. So it has a camera, it has a LiDAR, and yes, we colorize that LiDAR. Yeah, of course, the camera is calibrated to itself and to the LiDAR as well. So if you, and I think, Corey, in that data set, the PO tree that you showed, we should be able to see that not only is the colorization accurate, but it also matches the LiDAR intensity.
Unfortunately, that data set was flown without a camera, or the camera was not enabled. So we won't be able to show it on this data set, but we can certainly collect, we have other RECON-A data sets that we can provide.
Yeah, we should have a lot, yes. So yeah, if you would like to see a data set where the colorization matches, well, both with other photos and also in terms of exposure compensation, and it matches the LiDAR, then I think we have a lot of data sets to choose from.
Absolutely.
Okay, we've already addressed the question of whether LiDARMill can process or import raw L1 data. What about L1 data that's already been exported from Terra?
Yes, LiDARMill can definitely import LAS files, so LAS and LAZ, in any coordinate system. And you can also import trajectories. So yeah, that's something that is kind of, you can already try it. You can import a LAS file and a trajectory, because I think the Terra does export SBET files, right, Corey?
Yes, that's correct.
Yeah. And yeah, then you can run some form of trajectory optimization on it. It's just not something that's like well tested right now and that we would want to advertise. But yes, you can upload just a point cloud to have it hosted, or you can upload a point cloud and a trajectory and run optimization on it.
And for those that don't know, like Ben's saying about the sharing and hosting capabilities, you can upload any LAS or any LAZ. It could be a terrestrial scan, and you could use it in our cloud viewer or in that shareable cloud viewing link.
Okay, I'm trying to see if there's any more questions here. Here's a very general question. What is the accuracy of our LiDAR? I don't really answer that.
Yeah, that's very
yeah. Well, on the data set that we were showing, we had an absolute accuracy of 2.9 centimeters. RMS-EZ.
Yeah, it's a really hard question to answer because it depends on how reflective is the surface, what's the distance to the surface, sometimes what is the scan angle, so is it directly below the UAV or is it to the edge of the swath, and there's a lot of factors, so it's really hard to give one number. Yeah, and yeah, it also depends on how well do you fly, which often comes with experience. Yeah, it's a pretty complex question to answer. But
Certainly.
I think the 2.9 is a good, yeah.
And then for those that I don't think I mentioned it, that those flights were all flown at 80 meters for reference. 80 meter AGL.
Okay, and I think okay, here's a good question. What's the flight time with on the M300 with the RECON-A?
I think it's somewhere around 20 to 25 minutes. I'm risking misspeaking here. Lido, do you know better?
I was going to say 24.
Right,
So yeah, I think that's a good answer. Yeah, depending on wind and a lot of variables, but from our pilots, it sounds like 24 minutes is what we've been getting with these.
And at mean sea level, we should say, right?
Right.
We once had a customer a couple of kilometers above mean sea level, and they were unhappy about flight times. So at mean sea level.
Yes, where we have thicker air. And here's one that I don't know if you want to get into today, but someone's asking for a quick comparison between the RECON-A and the RECON XT. Do you want to give a 10,000 foot overview?
Yes, the RECON XT is a 360-degree scanner with 32 lasers. The RECON-A has 6 lasers and has a like 80-degree cross track times, I think around 4 or 5 degrees a long track. So it's got a much wider field of view. It has a bit longer range, and most importantly, it is more accurate. And it also lends itself to mobile mapping because of the 360 degrees field of view, and also for SLAM, which is maybe possible to do with the field of view of the RECON-A, but doesn't really make a whole lot of sense. So I would say the RECON XT is usually a little more flexible when it comes to applications and a bit more accurate. Is that fair, Corey?
That's fair. Yeah, you nailed it.
Okay.
All right. That sums up all of our questions. Ben or Corey, do you have any closing comments you want to add?
Thank you, Corey. Good job. And if you guys have any questions, then please hit up, if it's technical, maybe support, and if it's less technical, then sales.
Absolutely. Yeah. Thank you all for attending this webinar, and we hope that we got all of your questions answered. And, feel free to contact sales@phoenixlidar.com if you're interested in the RECON-A promotion. You can also go on our website, phoenixlidar.com, and see our products. And there's also a chat there that you can chat with different sales or support representatives. You can find us on Facebook, all the social media platforms. But yeah, stay in touch and tune in next month for our next webinar.
Yes, absolutely. A recording of this webinar will be available on our site, phoenixlidar.com, in the news section. And like Corey said, do follow us on all our social media platforms, including Instagram, Facebook, YouTube, Twitter, and LinkedIn. So thank you very much. For all of us here at Phoenix LiDAR Systems, we appreciate you tuning us in, and we'll see you next time.